Hello, my name is Maurice de Klein. I'm a researcher at the Spatial Information Laboratory, VU University Amsterdam. And in this video, I want to tell you something about the research project that we are working on. The research that I'm presenting is part of a larger project, which is called Mapping the Via Appia. But I will be in this video focusing on the information system that we have developed. Because in a unique collaboration between archaeologists and computer scientists, we have developed a 3D digital environment that allows archaeologists to analyze their study area virtually. So let me first tell you a little bit more about the archaeological background of this project. So the Via Appia is known as the first paved road in Europe. It was the construction started in 312 before Christ, and it ran from Rome all the way south to Brindisi, and it had really important military, economic, but also an important social and funerary function. Because what did the Romans do? The Romans did not bury their dead inside of the city, but they did it outside of the city. Our study area is the area between the 5th and 6th mile from Rome, so we are really near to the old city. So the ruins that we see are the funerary monuments from antiquity. And we also see some bricks that were put there on display. They were put there like museum pieces. And these correspond to the development of the archaeological park in the 19th and beginning of the 20th centuries. These trees are from the same period, and we still see the road with small cobblestones. Those aren't antique, those were put there quite recently. So here is a reconstruction from the 19th century, and what we want to do in this project is a kind of similar thing. We want to reconstruct how it might have looked like and how all these monuments might have looked like. So the first thing that we did is that we went into the field with a tablet and filled in all kind of characteristics of all the objects that were scattered around. The second thing that we had to do is that we had to measure our study area in 3D. For this we collaborated with the Fugo company. They went all the way to Rome with their Drive Map application, and there was a car which had a laser scanner inside, a GPS and a photo camera, and they produced this really large XYZ coordinate point cloud. However, what this car doesn't do, it doesn't give us the backs of all these objects. So we used a different technique to allow get the backs of all these objects to get the whole object. The technique that we've been using is called structure from motion. Structure from motion is basically taking a lot of pictures of one object and putting it into an algorithm. This algorithm will look at all the pictures, and by searching for patterns in the pictures, it can automatically process into a 3D model. However, the 3D models are not referenced and scaled yet. The Fugo point cloud is. So we have used the Fugo point cloud as a reference system to reference all these individual 3D objects generated by structure from motion. So we have all these characteristics from all these objects in the database. We have this XYZ coordinate really large point cloud, and we have for every object we have this structure from motion object. We have put all this data on our server and we have put it somewhere in the cloud. On top of our cloud, we have developed several applications. So the first application that I want to show over here is the desktop application. The main advantage of the desktop application is that it allows the archaeologist to add and adjust the data. However, it is not very easy to use. So the second application that we've been developing is a web application. And this web application is primarily meant to analyze and explore the data. Since we are working according to certain standards, we are also capable of exporting our objects to 3D modeling software. And especially within this 3D modeling software, we are capable of developing these 3D reconstructions of how our interpretations of how these objects might have looked like. We are also capable of exporting it in such a way that we can print it. So the good news about our project is that we have foremost been using open source software, and that we have published all the code that we produced online. So let me show you the 3D GIS that we have developed. So first we see a desktop application. We see the desktop application. So what do we see over here? We see structure from motion objects referenced in this point cloud from this Drive Map. Here we see two great monuments over here. We see some decorative stones over there, and we saw this really large object in the back. So this is the web application. So you just go to a browser, Google Chrome, Firefox, it will work. You just go to the website and log in, and you will be able to browse to the study area. And what's happening now is quite spectacular, because we're zooming out. We see now gigabytes of data being displayed on our screen only using a web browser. So there's a lot of database structuring and a lot of tooling and processing going at the back. But that's really nice to browse to the area and to go through it. But it's nicer if we can query our data set. So we have all this data, all these characteristics collected in the field, and we are capable of querying it. Now we're going to zoom into one of these objects. This is a kind of pyramidal funerary monument. So let's zoom into that. So let me tell you a bit more about this funerary monument. What we are looking at is nowadays only the core, because in antiquity it was full with marble plates and travertine rocks attached to it. However, they are removed, because Rome used to be a city of more than 1 million inhabitants in antiquity. In the medieval time, Rome was a small town. It only had 50,000 inhabitants, and one of the products that they exported were these marble and were these travertine stones. You can still find them in small churches in the south of France and even in the south of Germany. So what we are looking at as archaeologists are basically the scars from where these marble and travertine blocks used to be. And by analyzing these scars and by measuring it, we are capable of putting them back in place, but then virtually. So over here you can see we found some scars of this kind of anchor that attached the travertine blocks to the facade of this concrete core that is still left. We're looking at these small traces, and by analyzing them thoroughly and comparing them with other objects in Rome or in other parts of the Roman Empire, we are capable of reconstructing it, and we are capable of providing our own interpretation on how we believe that it might have looked like. And this object for instance, since we found a lot of small stones with an angle of 60 degrees, we reconstructed it to have a pointy roof. However, of course, we are not certain. It can either have been a flat roof. In this video, I've showed the 3D information system that we've developed for archaeologists for the Mapping the Via Appia project. I hope you enjoyed it. Of course, this project would have never been able without our partners. You can see them over here. More information about the project can be found at our website www.mappingtheviaappia.nl. Thank you for watching.